Hey everyone, in this video I'm going to be making ferrofluid, which is a liquid that responds to magnetic fields. And to do this I'm going to use the iron 2 chloride and iron 3 chloride that I produced in a previous video. And the first step is to mix that with household ammonia. So what I've got here is my iron 2 chloride, the green solution, protected from air since it'll very easily oxidize to iron 3 chloride as we've seen. My brown iron 3 chloride in here, and 150 milliliters of ammonia solution in the large beaker. So the first step is to mix together the two iron chlorides. And you want to have these in a ratio of 2 to 1 iron 3 chloride to iron 2 chloride. So I've tried to do that with concentration and volume differences here. So I'm hoping that this will work out, even though I didn't quite exactly measure out the precise quantities. So now that those are together, we'll mix them with the 150 milliliters of ammonia. You can see that generates a significant amount of heat and a good bit of steam. And what this does is it produces magnetite. Both of the iron chlorides react with the ammonia in a complex reaction to form magnetite and ammonium chloride in solution. The magnetite precipitates out as solid particles. And actually, now that I think about it, this steam is probably just ammonium chloride, like in my previous video where I mixed ammonia and hydrochloric acid, because there's going to be leftover hydrochloric acid in my iron chloride solutions. So you can see here now we've got this really black precipitate of magnetite particles, which is also called black iron oxide, Fe3O4. And I'm doing this outside, by the way, because I'm using ammonia, which has a very bad smell to it, as well as both of my iron compounds seem to stink a little bit. I think that's just because of the way I made them using iron wool. So now that I've done that, what I need to do is heat this near boiling for a little while. And the reason that I'm doing that is to drive off the excess ammonia as a gas. So I've brought my hot plate out here. I'll put that on there and put it on high and just let that heat up. And then once this heats up, I'm going to be adding oleic acid. The reason for that is because it acts as a surfactant. So the oleic acid, when it's first mixed with the ammonia, it creates ammonium oleate, which is a slightly soluble soap. And then the heat will break this down back into ammonia gas and an oleate ion, which remains in solution. That oleate ion will then attach itself to a magnetite particle. And enough of these oleate particles surround a magnetite particle, and then it can be suspended in solution, so it won't just fall out. So that's what you need in a ferrofluid preparation, is some kind of surfactant, and that's what the oleic acid is going to be for. So like I said, we'll just heat this up, and let's get to the next step. Okay, the solution's been heated. Now I'm going to add 5 milliliters of oleic acid. I actually have a little bit more than that in here because oleic acid is pretty thick, syrupy consistency. So there's going to be a little bit stuck to the walls of the cylinder here. So just to ensure that I get all 5 milliliters in there. I'll give that a good stir. At every step of this process, you want to swirl the solution rather often, just to make sure everything is mixed consistently, because the magnetite is going to want to settle out since it's a heavy solid. So you want to keep everything suspended as well as you can. So now we're just going to heat this until most of the ammonia smell has dissipated from it. So again, that's why we're doing it outside, is because this step produces ammonia gas. So that's going to take about an hour. So we're going to leave that to go for an hour with regular swirling as it heats. Alright, I've had this heating for about an hour and a half now. I haven't noticed much of a change in a little while, so I'm just going to stop the heating now and let it cool off. So I'll turn the heat off and let it cool down on its own. There hasn't really been much of a change in volume over the whole time. That's a little hard to see because there's so much magnetite coating the sides of the glass too. But there's bits of magnetite floating around in the solution. Alright, the solution's cooled back down, and I brought everything inside because it's getting dark out. So the next step in this is to add a carrier for the ferrofluid. So now, so far in the process, we've created our magnetic responsive material, which is the magnetite, and encased it in a surfactant, oleic acid, which prevents it from sticking together. So now the final step is we have to add a carrier fluid for it, and my fluid is going to be kerosene. So I'm going to add 100 milliliters of that to the solution. So the idea of this is that the oleic acid magnetite system is not soluble in water, and it is soluble in kerosene. So basically what should happen is the oleic acid that has the magnetite particles trapped should migrate to the kerosene layer, and then I can just decant that layer off, and that will be my finished ferrofluid. So I'll add the rest of this. This part you should also be doing outside because kerosene puts off a lot of fumes, but like I said, it's dark, so I figure I'll finish it off in here. And so to mix everything together, I'll just throw my stir bar in there and let it stir. Alright, I transferred everything into a beaker so that it'd be easier to pour. And now you can see that everything is clearly separated into two distinct layers. The bottom layer is the water, and the top layer is kerosene, which is where all of my ferrofluid particles have migrated to. So that should be the entirety of my ferrofluid liquid. Let's see how this reacts. Clearly, it's attracted to a magnet. There you have it, homemade ferrofluid. Thanks for watching. So it turns out it's kind of a dumb idea to use a magnetic stir bar in a liquid that's attracted to magnets. Go figure. At least it looks cool.